Hi folks, today we're going to talk about graphing parabolas and identifying features. Now, as you let that title sink in, you might think to yourself, well, we've already done that. We've already graphed quadratic equations. We've already identified key features like the vertex and the axis of symmetry, the y-intercept, the x-intercepts. That's what we've been doing for a long time. And that's true, but today we're going to include standard form, but standard form of a parabola, not standard form of a quadratic function, but standard form of just a parabola in general. And the difference is that standard form today has two different formats. One of them is where the parabola opens vertically, so either up or perhaps it opens down. But then the other version is when the parabola opens to the side, so it'll either open to the right or it'll open to the left. And the reason that this standard form is a little bit different is because it's not standard form of a quadratic function. This itself is not a function, because if I put a vertical line here, then the parabola does not pass the vertical line test. I have it touching 1, 2 times, and so that's a failure of the vertical line test, and this is not a function. So today we're talking about a different type of standard form of a parabola, and there are two different versions, one where the parabola opens vertically and one where it opens to the side. So let's go ahead and fill in our notes. A parabola is the set of all points in a plane, so just kind of like a surface, that are equidistant. Equidistant means equal or same distance. Very literal kind of breaking up of that word, equidistant. So it's the set of all points in a plane that are equidistant from a fixed line, fixed meaning not moving, a fixed line called the directrix. Like director and tricks. Directrix. So the set of all points in a plane that are equidistant from a fixed line called the directrix, and a fixed point not on the line called the focus. So these are new things that we are discussing today. We're kind of adding some key features and some things that you can use to describe a parabola's graph. The focus, so this new word right here, the focus, is always inside the parabola. And it's a point. So if I look at my two pictures here, focus is right here. So it's a point that's inside of the parabola. In this type of parabola, the focus is here, again, inside of the parabola. So it's kind of like in the cup of the parabola. There are two different standard forms for the equation of the parabola, as I had mentioned here before, here and here. Now look closely at those standard forms. You'll see that a lot of things are the same. The minus h, the minus k, the squared, the 4p. But the things that are different are the x being squared and the y naught, or the y being squared and the x naught. So something that you want to make sure you understand is that whenever your parabola opens up or down, then the x is the thing that's being squared. Just like normal quadratic functions that we've discussed. Y equals x squared, parabola opens up. Y equals negative x squared, parabola opens down. But if y is the variable that's being squared, then that means your parabola opens sideways, either to the right or to the left. So if y is being squared, this means it opens to the side. So let's move on to some important parts of standard forms. We're not going to discuss everything right now that's on the first page of this set of notes, because we're going to come back and refer to it in our actual examples. But what we do want to make sure we point out is that if 4p is positive and your parabola opens either up or down, if this is positive, that means that the parabola opens up. And if this is negative, that means the parabola opens down. It's kind of like the a value when we talked about standard form of a quadratic function. Now it's also possible that 4p will be positive or negative over here when the parabola opens sideways. And obviously that means that your parabola won't open up or down, but it will change direction based on your 4p. So if the 4p value is positive when y is being squared, then the parabola is going to open to the positive direction. It's going to open to the right. But if 4p is negative, then the parabola is going to open in the negative direction and it's going to open left. So these are things that you definitely want to make sure you memorize. So the axis of symmetry here will be x equals whatever the x value of the vertex is. Remember that the vertex is h comma k. That can be located here and here. It gives us a way to calculate the ordered pair for the focus and the equation of the line for the directrix. It also gives us something called the focal chord, and the focal chord is a line segment that stretches from one side of the parabola to the other, and it goes through the focus. So this right here, this is the focal chord. And one of the characteristics that you're going to be asked to find is how long the focal chord is for the parabola. If the focal chord is smaller, that means that your parabola is skinnier. If your focal chord is bigger, that means that your parabola has to open up wider in order to accommodate a bigger focal chord. So the focal chord length is going to become a key feature for us today. So I'm going to keep this page handy because I'm going to need some of this information here. So I'm going to keep it handy off to the side. To graph a parabola in standard form, first you need to figure out the direction. So you need to figure out if your parabola is opening horizontally or vertically. If x is being squared, remember that's normal, that's vertical. So either it's opening up or it's opening down. But if y is being squared, well, we really haven't seen that very much, so that's going to be opening horizontally. So either to the left or to the right. So first you need to determine which direction your parabola is facing. Is it vertical? Is it horizontal? Is it opening up or down, or is it opening to the left or to the right? That's all based on the 4p, if 4p is positive or negative. And think about what would make sense. Of these four choices, the two that kind of go with a positive would be up and right. So if 4p is positive, then it's either going up or right, and you just have to determine which way. Are you opening vertically up or are you opening horizontally to the right? Down and left typically go along with negative values. Again, if you have a negative 4p, you're either opening down or left. You just have to determine which one. So if x is being squared, you're opening down. If y is being squared, you're opening to the left. So you have to determine how you're opening the parabola. You need to find the vertex, h comma k, but you need to be careful because depending on what's being squared, your h and your k fall in different places. The h value is always with x in the equation, and the k value is always paired with y. And I'll show you what I mean. I'm going to scroll, well, you can scroll. I'm going to flip back to my first page. And look, h is paired with x, h is paired with x, y is paired with k, y is paired with k. So even though the x and y's are in different locations in each of these standard forms, x and h are always paired together, y and k are always paired together. So keep that in mind whenever you are trying to identify the vertex. Next, I need to find p. So I'll set the coefficient of the non-squared term equal to the absolute value of 4p, and I'll solve for p. So I'll show you what that looks like in our first example. And then you'll want to plot the focus, which is a point, and the directrix, which is a line. And you'll use the focal chord to graph, to show how wide the parabola should be. So in example 1, first thing I want to do is identify what variable is squared. Is x squared or is y squared? Well, x is squared here, so I'm going to go to my front page and I'm going to write my standard form when the x variable is being squared. And I'm just going to write it right on top of the equation so I can kind of identify what pieces have what values in this example. So x minus h squared equals 4p times y minus k. All right, so some things that are missing in this equation. I don't have x minus anything. This is just x. So it's kind of like x plus 0 squared, right? So that h value, it's got to be 0. Equals, well, there's a number out in front of y, that'd be 8. But there's no minus k going on, so this should also be y plus 0. There's no k value that's happening. So let's talk about the direction. The direction that this graph is opening. Well, if x is being squared, are we opening vertically or horizontally? We're opening normally, so that would be vertically. Because x is squared. Now, if we're opening vertically, that means I can either open up or down. So look at your 4p value, that coefficient in front of the non-squared term. Is it positive or negative? It's positive. So vertically, that means if I'm opening in the positive direction, I'm opening up, because the 4p value is positive. My vertex is h comma k. Well, there was nothing here and nothing here, so that's a 0 comma 0. The p value, well, p comes from here. And the thing that's in the place of 4p is 8. So if I set 4p equal to 8, well, now you have a very small one-step equation to solve for p. I would divide both sides by 4, and I would have 1p equals 8 divided by 4, which is 2. So my p value is 2. So now we're kind of getting into the area that is unknown to us. The p value is new, the focus and the directrix and the focal chord, those are all new. So I'm going to go back and I'm going to look at my first page, and I'm going to look at how I'm supposed to find the focus for a parabola that opens vertically. So here's my equation for a parabola that opens vertically. My focus is the point h comma k plus p. So h comma k plus p. Well, what is my h value? 0. What was my k value? Also 0. What's the p value? 2. So 0 plus 2 is 2. There's my focus. The directrix is new to me, so I go back and I look at the reference for the front side. My directrix is a line. It's y equals k minus p. Y equals k minus p. So y equals k, which was 0, minus p, which is 2. So 0 minus 2 is negative 2. That's the equation of the line that's the directrix. And finally, the focal chord. The focal chord is the absolute value of 4p. Absolute value because we can't have a distance that's negative. That doesn't make sense. So the focal chord will always have a positive value because it's a distance. So 4p is my focal chord. Well, I go look at 4p. The absolute value of 4p here is the absolute value of 8. 8 is in the spot of 4p. So my focal chord is 8 units through the focus. And I'm going to have a little set of parentheses down here because we're going to use that in a second. So whenever I plot, I'm going to plot my vertex at the origin, 0, 0. I'm going to plot the focus at 0, 2, 0, 2. I'm going to plot the directrix at y equals negative 2. So y equals negative 2, that's this line right here. I know that my parabola opens vertically and up, so it's going to go through my vertex and it's going to go up like that. But my focal chord goes through the focus and it's 8 units long. That means that it's half the units on one side and half on the other. So 4 left and 4 right. So I'm going to go from my focus and I'm going to count 4 units to the left, 1, 2, 3, 4, and 4 units to the right, 1, 2, 3, 4. And through my vertex, I'm going to go through the endpoints of my focal chord. So this right here, this is my focal chord. Okay. Let's try another example. Identify the direction this is opening, so what's being squared? The x variable. So are we opening vertically or horizontally? We're opening like normal, so vertically. If we're opening vertically, how are we opening? Up or down? Well, I look at my 4p value, my coefficient of the non-squared term, and that's a negative, so I'm opening down. I need to start understanding my vertex and P and focus and directrix, so I need to make sure that I write the correct standard form of a parabola that's opening vertically. So x minus h squared equals 4p times y minus k. My vertex is h comma k. My h is right here, but remember I have to switch signs. So instead of positive 3, it's negative 3. My k is right here, so if I subtract k, and here I'm subtracting 2, then 2 is my k value. So I kind of switch my signs. The p value I get from doing a little bit of math. If 4p equals negative 12, then what does p have to equal? Well, if I divide by 4, p has a value of negative 3. My focus, if I go to the front and I look at the correct graph, my focus is h comma k plus p. So I'm going to fill in my values of h comma k plus p. My h value is negative 3. My k value is 2. If I add -3, 2 plus -3 is like 2 minus 3, so that's -1. There's my focus. The directrix, I don't remember how to get, so I'm going to look at the front of my notes. The directrix is the equation of the line y equals k minus p. So y equals k minus p. Y equals, k is 2. If I subtract -3, that's minus -3. That's like 2 plus 3, so 5. And my focal chord is the distance of 4p. And if it's a distance, I take the absolute value of 4p. So the absolute value of -12 is a distance of 12. So 12 units through the focus. 6 on the right side, 6 on the left side. So when I graph, my vertex is at -1, 2, 3, +2. That's the vertex. My focus is at -3, -1. My directrix is the line y equals 5. So 1, 2, 3, 4, 5. Here's the directrix. My parabola is never going to cross the directrix. It's always going to cup the focus. Remember, the focus is on the inside of that parabola. So that reinforces that my parabola is opening down. My focal chord through the focus is 12 units. So half on the left side, half on the right side. Half of 12 is 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And my parabola will go through my vertex and through those endpoints of the focal chord. There we go. And this is the focal chord. All right. Let's do example 3. What's different about this one? What's being squared? The y value is being squared, so that means that the direction that it's opening is not vertically, it's horizontal. Because y is being squared. So I'm going to take a moment and I'm going to write my standard form when y is being squared, when it opens horizontally, so that I know where all of my values are. Y minus k squared equals 4p times x minus h. My 4p value is positive, so horizontally the positive direction is opening to the right, because 4p is positive. My vertex, be careful, the h always is with the x. So here is the h value. The opposite of -1 is +1. The k is with the y variable, so the opposite of -2 is +2. The p value I get by doing my small little equation when I set these equal to each other. So 4p equals 4. If I divide both sides by 4, I get p equals 1. My focus, I don't remember how to find. So I make sure I look at the correct type of graph. And my focus is h plus p comma k. H plus p comma k. So h is 1, p is 1, so 1 plus 1 is 2, comma k, which is also 2. My directrix, I don't remember, so I go look. In the horizontally opening graphs, the directrix is the equation of the line x equals h minus p. X equals h minus p. So x equals h, which is 1, minus p, which is 1, and 1 minus 1 is 0. And the focal chord is the absolute value of 4p. So 4p is 4, and the absolute value of 4 is just 4 units. Half on one side, half on the other. So 2 on one side, 2 on the other. Let's graph. The vertex is at 1, 2. The focus is at 2, 2. Remember that the vertex is opening to the right, which is good because it needs to kind of cup the focus. The directrix is the line x equals 0. So it's the y-axis. And then my focal chord is 4 units. So 2 on one side, 2 on the other. If my graph opens this way, then that means that my focus is 1, 2 on the top and 1, 2 to the bottom. And here is my parabola with my focal chord.